For anyone who's serious about architecture, I strongly recommend The Art of Systems Architecting by Rick Meyer. This is not an easy read, but it's a pretty thorough examination of the concepts of system architecting across a wide variety of domains, including politics, including healthcare, including aerospace and so on. And part of their effort is to address the universality of issues involved in developing systems architecture. The single most valuable thing for this book is Appendix A, which I go back to all the time, which is about 150 heuristics for systems level architecting, which are things, I mean, this is, just to give you an example, just the first few here. In introducing technological and social change, how you do it is often more important than what you do. If social cooperation is required, the way in which a system is implemented and introduced must be an integral part of its architecture. If the politics don't fly, the hardware never will. Good products are not enough. Implementation matters. Success is defined by the beholder, not the architect. The strengths of an organization or system in one context can be its weaknesses in another. Know when and where. There's nothing like being the first success. And my favorite from Bob Spinrad in there is, in architecting a new software program, all the important mistakes are made the first day. I have quoted that in court, because I think I've told you guys before. So those are two good books I'd recommend for someone who wants to pursue software architecture as a profession now or later in your career. Okay, The Longest Yard. Ruby Raley and I wrote this. Ruby is a good friend. We met at a IT conference where I gave a presentation. And she came up to me afterwards to ask me some questions and pick some issues with me. Then ended up I was at OSG, and she hired me from OSG to come in and do some mentoring on software architecture for some of the people working with her. She was at a global logistics firm. She's actually one of the best IT product managers that I've ever known. Utterly, cold-bloodedly realistic, which means she's usually in fights with upper management, because she says, no, this is how long it's going to take. You know, I don't care when you need it. This is what it's going to be. And she and I wrote this article mostly because we had both discussed this issue for some time, which is that the approach followed by most of industry in hiring and managing IT people really derives from a manufacturing mindset. I mean, we're back to the mythical man month. It's kind of like, okay, we need 10 programmers. You know, it doesn't matter how good they are or whatever, so we need 10 programmers to do this work, and they're going to do it, and they'll get it done in 6 months, and so on and so forth. And we wrote this article. Now, the big caveat here, no one's ever hired us to, individually or together, to try and actually implement this and see how well it works. But we wrote this article basically saying, here's a different mindset that you may want to consider, which is to approach IT recruitment the same way you'd approach it from a professional sports team. And we use football because we're both football fans. Okay, IT recruiting often focuses on, I mean, one of the problems right off the bat is a lot of IT recruiting is done by HR.
Oh, wow.
And they're given, okay, we need this. There's a famous story from the late 90s of a corporation that put out an ad for developers with 5 years of Java programming experience. They did this 3 years after the Java language came out. Okay. I mean, a lot of HR will say, oh, well, you have to do this and do that, you know, check this and so on. It's one of the problems, it's one of the reasons why if you haven't learned this lesson already, the best way to get jobs is to network. You want to bypass HR, trust me. You really want to bypass HR if you can, which is often easier said than done, but that's a whole nother long lecture. What do sports teams do when they want to add people to their team? They look at actual people out there doing stuff. They see what their successes are. They look at their talents, what they've achieved. Then they go after them to try and hire them. The usual approach within IT is, okay, we'll post a position, we're going to get 300 resumes in, or maybe 3,000, and we'll sort through and try and decide on the basis of these resumes who we want to call and talk to. There aren't a lot of organizations that go out proactively and say, what kind of reputation does this person have? Before we even contact her or him, what do we know about them? Where have they worked? What have they done? Again, a lot of them, they focus on some of the issues, talent, education, professionalism, experience, skills, and so on, but they tend to often do a checkbox, or worse yet, one of my pet peeves, here's this puzzle. How would you decide to estimate the number of service stations in the U.S.? Microsoft, Google, a few other companies are notorious for doing that. There have actually been some articles recently that basically say that's a really crummy way of trying to hire people. What you get is you get people who are good at that, or who have read books on what the proper approaches are. And it really tells you nothing about their ability to actually deliver a workable design or architecture or implementation design. You have a lot of hiring for the sake of hiring someone. Most professional teams work with a team size limit, usually imposed by the league. Often they'll work within a salary cap. Whereas what you'll often get in hiring is the idea of we just need to hire 10 more programmers, and we can get this done because we can divvy up the work among them. I added this last item from last time I gave a lecture, and I think it's an article. Avoid hiring, overpaying new hires, and underpaying proven performers. I think I mentioned a class or two ago, my daughter Crystal's been dealing with this. Because the job market here in Utah is so hot, there have been new people. She's been there for 2.5 years now. There's been new people coming in who are still unproven, who are new hires, who are getting $10K a year more than she was getting. And that's a great way to lose your best performers who are there. And she talked over with me, and I said, go talk to your manager, and suggested some approaches. And she was thrilled because she came back and they were actually offering her a very substantial raise and a promotion and moving her on to something because they recognized that she's good. And they were very thankful for her. I mean, her manager basically said, thanks for coming for us, thanks for approaching this in a professional manner. And she's tickled because she's basically being made whole on this end.
How did you find out how much they were paying newer people, or how?
I'm trying to think of how it came out. It came out somehow.
Oh, okay.
And some companies will have completely open salary policies. Some will have completely closed salary policies. Yes.
In the U.S., you can talk about your salary, though. If they fire you over that, then you can take that to court.
Yeah.
So in the U.S., you probably should be talking about your salary to make sure that you're within what other people are being paid, or what you should be paid, depending on how good a programmer you are and what your position is.
And sometimes you can find out simply by looking for current posted job positions within your area and your profession. It's kind of like, oh, hey, look, there are these 3 companies here at Thanksgiving Point that are all offering $5,000 a year for new hires with no experience. Organizing the team. Quarterback, chief software architect, most visible player, directs efforts. Now, for those of us who watch football, you know that a great quarterback can often compensate for weakness in a team, and vice versa. A great team can compensate for weakness in a quarterback. But you really need a good solid quarterback and a good solid team. Because otherwise, sooner or later, it catches up with you. You know, you want the focus to be on team achievements, for teams to be rewarded as teams, because otherwise you start to engender competition. And you know, okay, let's talk about a negative from sports. You know, you have someone who just, you know, a great defensive lineman just renegotiates his contract and is now suddenly making substantially more money than anyone else on the defensive line. And what happens to everyone else on the defensive line is kind of like, hey, wait a second. And if you're performing, it's kind of like, well, you know, I'm going to wait and see what I get in free agency, or they're going to have to come up with some big money, and it sort of keeps ratcheting up. Coaching, you know, it's surprising, and this is probably, if you take nothing else away from the article, remember this: IT organizations devote, generally speaking, remarkably little time to coaching their personnel. They sort of expect you to know how to do everything. They don't give you any practice stuff, and they don't bring people in to say, here's the best thing to do this. Now, I'm sensitive to this because at OSG, this is a lot of what we did. We came in, when I was at OSG, we'd be hired by corporations like Fannie Mae or Capital One and so on, and we'd come in and be mentors. We would work with their architects, we would work with their developers, we would work with their quality assurance personnel, and review what they were doing and say, okay, here are some other things that you might want to do. And so we would do a knowledge transfer and experience transfer. We'd say, try this out, and come back and report to us. In effect, we were doing coaching, and we would improve the quality of the IT organization we were brought into. A lot of IT organizations actually have the people qualified to do that within them. They're just not being used to that extent. Likewise, teams, you'll often hear about a team's philosophy or its overall approach. And for sports such as, say, football, you'll have playbooks that say, in this situation, here's what you want to do, here's how you want to solve it. So you have this encoded approach to specific problems, and you have overall philosophies. But again, a lot of organizations will be very ad hoc, and you'll actually get a lot of disjunction between how one team is approaching a particular type of problem and another team is approaching the same problem. And if those two systems ever have to mesh up, it will be into you. Now, team rules, actually I had someone talking about Agile. Come on. Here's the Agile Manifesto, which I really like. I don't see Agile as a silver bullet, but what I really like about the Agile Manifesto and the Agile principles is exactly this. You have a small set of clear rules that basically say, this is how we're going to approach these problems. With Agile, as we value individuals and interactions over process and tools, working software over comprehensive documentation, so on and so forth. You also have within Agile, there are 12 principles. So this type, and I'm not saying go out and adopt Agile, but these types of rules are important. Carol Teasley at Fannie Mae, whom I mentioned, had a set of rules for anyone who worked for her. And she would hand them out and said, this is how, these are the things that are important. These are the do's and don'ts if you're going to work for me. I have that in my file somewhere, but again, that's buried in the boxes in my basement. But it was very effective. Because when there were issues with individuals on the team, she would look at them and say, remember this rule? What you're doing here doesn't follow that rule. Explain to me why you are violating this team rule. Playbooks. IT equivalent of playbook. development heuristics and maxims, we talked about some there. Design patterns, language standards and guidelines, things that get the developers on the same page, metaphorically and sometimes literally. You want to try and promote, I know I used to irritate at pages. I had coding standards at pages. It was Objective-C, it was for next step and so on. And I had a coding standards guideline as far as documentation, as far as how the code was formatted and so on. Not all the developers would follow it. And if I was in the middle of either writing code or debugging and I ran across code someone else had written that didn't follow the guidelines, I'd sit there and rewrite it so it did. And I know there were 1 or 2 developers who were sort of irritated like this, but it's like, guys, we have 500,000 lines of code here with a lot of different people touching it. I don't want barriers to people understanding what's there. It needs to follow consistent naming, consistent formatting, and so on. Performance, offense, development. And Ruby did a lot of this, that basically adaptive. Agile stuff is sort of the equivalent of West Coast, pass-heavy stuff. Lots of flexibility, moving very fast. Go fast, go hard, for those who remember Robert and I. The East Coast is sort of predictive. Waterfall is a 3 yards on a cloud of dust, run heavy. Iterative is more balanced, where you're doing both things. Why do you use one or the other? Adaptive, Agile, XP is better geared for smaller projects with much tighter development cycles, where you need to be very responsive to market requirements and so on. A more methodical, waterfallish, because they're all iterative in the end, but a more methodical, waterfallish one is better adapted for things where you have to take the time to think the architecture through carefully before you're done. Defense, quality assurance. I'll let you read the article on this. I mean, we're talking about different types, because you don't go with just one defense. Defense depends on the situation. We're going to have substantial lectures on quality assurance later on. Dealing with the front office. This is probably the other, aside from coaching, the other most important thing out of this article. These are, my observation, tend to be in priority for each what business cares most about and what IT cares most about. What business cares most about is, first, we want to be able to compete. We have to have and these are business goals in terms of IT. We have to have the bare minimum in order to compete, which means we've got to be able to, we have to have accounting systems. We have to have, our own website. We have to do this, the sort of thing that you would expect from a business. B2 says, now we want better functionality to allow us to outperform our competition. So once you've sort of met the minimum functionality, it's like, okay, now we need the stuff that's going to give us a competitive edge. And then above that, we want efficiencies and productivity. And I'll tell you right now, for a lot of business, you know what that means? Reduced headcount. They want to accomplish things with fewer workers. But they want efficiencies and productivity to allow the firm to free up funds for investment, expansion, profits, so on and so forth. Now, what does IT care about? Well, first, we want to keep our people. And if possible, we want to grow our staff. Then we want to have the money and time to get off of this old technology that we're stuck with. We actually want to migrate a number of systems off of Windows XP, because we're no longer getting security support from IBM from it. I don't know how many of you are aware that one of the great factors, you guys are older, there was a recession that hit basically in 2000, 2001. Part of it was caused by the collapse of the stock market following the collapse of the dot-com boom that was leading up to that. Part of it, which a lot of people don't realize, is because here in the US we spent $100 billion repairing Y2K issues. And a lot of that was business migrating off of old archaic systems that they had not found the economic justification for replacing until Y2K came along. It was cheaper just to say, okay, we're moving off this old software and hardware completely. What you had was this massive IT spending running up through the end of 1999, early 2000. And it pretty much depressed corporate IT budgets for about 4 years. And so the IT industry was hit, got a double whammy. The dot-com bubble popped in terms of stock, and corporate IT stopped spending money because they'd blown through the equivalent of several years' budgets in trying to fix Y2K. And NASDAQ, which is mostly tech stocks, peaked in March of 2000 and then started a long decline and did not cross that March 2000 peak again until about 6 months ago. It took 17 years for the NASDAQ index to recover from where it had peaked in early 2000. Anyway, the 3. Keep the business side happy, or at least off your back, while getting the funds necessary to accomplish IT1 and IT2. You need to be conscious of these differences. This gets back to the negotiations and love songs reading that you had last week. Because what you want in IT is often does not mesh well with what business wants and vice versa. They want to cut IT costs. At the same time, they want wonderful breakthroughs in IT productivity so they can cut other staff elsewhere. And what's really hard is getting, they have a certain level of spending that you have for maintenance of existing IT systems. And often by spending more, you can replace some of those and then lower IT costs as a result, maintenance costs. And they don't quite believe in that leap of faith to spend the money. And that's the end of that lecture. Any questions or comments? You're all kind of sit through. Okay. Let's see the last one here. You guys are getting a lot of time today. So, let's talk about software architecture and design. Your deliverable that's due this Saturday is your project architecture and design document. What is architecture? Thoughts? When I say software architecture, first you read the thing up there. When I say software architecture, what comes to mind to you?
A plan?
Plan? Okay. Yes?
Modules and, I guess, like lower modules, different setup.
Okay. Yep. What else?
Import statements.
Huh? Input statements?
Yeah, so you can import different classes of these.
Oh, import statements. Okay. Yes?
Really big diagram on Mr. Chart with a bunch of different classes.
Yep. Other thoughts? Yeah.
API.
API? Interfaces? Other thoughts? I've mentioned that when I was at Pages and I was doing the architecture for Pages, I had 3 diagrams that I came up with, all on big sheets of graph paper. One was the module interfaces. Here are all the major software components that have to talk to each other, and here's how they talk. One, because this was a desktop publishing system, was the architecture of a document. Here is what a document looks like, and it was in terms of object. It was basically an object composition diagram. Here are all the objects that are involved, here's how they relate to each other, and here's everything that goes into this big complex object. That's the document itself. And then the third one was the major class hierarchy, which actually had I think 4 parallel hierarchies that had to do with, it followed object document composition, but had to do with